Bismillah ar-Rahman ar-Rahim. This is the first episode from the series Camera and Photography. This episode was posted months ago in my channel, but it was in Arabic. This is an English dubbed copy, and it's very rich in illustrative examples, pictures and videos. Subjects discussed in this episode are similarities between camera and human visual system, the visible portion from the electromagnetic spectrum, which we call light, which is the basic pillar in photography. Some examples from the animal's vision and wild vision, like the horse, the hawk, the owl, the pelican, mantis shrimp, ford-eye fish, chameleon, housefly, and the bee. These examples were taken to understand the limitations of a human visual system. Also, the parts of a human visual system were discussed, the mechanism of vision and the pathway. At the end of the episode, some light was shed on the moving picture and how the human eye perceive and interpret these moving pictures. And thank you. Human eye is not the best among the creatures. Most of the birds can see much better than humans, especially cars, sometimes called the third eye of the horse. Equestrian, and for the horse groomers, they should know based on the movement of the ear. So the horse will not be able to make it, and the knight may be thrown off the back of the horse. The size of the eye is large relative to the size of the head. It can spot a fish inside the water from a 2,000 feet height. The owl can see infrared. It can hunt a mouse. You cannot see anything underneath. For these creatures, they can. And the lower part of the eye maintains the surveillance underwater. As if it were built on a telescope, it can see 3D. Each eye can search separately for the prey, and this is why it's very difficult to swat a fly, because it moves much faster than. And this Allah gifted feature for the bee enables it to see its bread easily. Cornea is transparent like a window. In low lighting condition, it gets wider. It will be adjusted to get a clear image. As well as near objects, the lens of the human eye will adjust itself. There's a time to refocus when moving from one object. They are used mainly in low lighting conditions. We'll collect all this information to draw the three-dimensional image, to form the image with its relevant color, brightness and depth. The breaks in the moving picture will be noticeable. There's a difference between sight and vision. They projected a statement by popcorn and Pepsi. They didn't see this statement, but their brains did. Bismillah ar-Rahman ar-Rahim. Our subject today is about camera and photography. And to understand how camera works, it's important to understand how does a human eye work. Because camera system is very similar to the human eye in its different parts and the mechanism of taking pictures. Human eye is not the best among the creatures. Most of the birds can see much better than humans, especially cars. human visual system has its limitations. And understanding these limitations is crucial, not only to understand the camera system, but also to understand the capabilities available in the human visual system and what can he perceive from the things around him. Before getting into this, it's good to remember the most important part in photography is light. And even the word photography is driven from the old Latin, which means drawing with light. You may use a commercial camera to take a picture in a room with good lighting, and you will get result much better than taking a picture for the same room with a professional camera, but with bad lighting. So light is a crucial factor in photography. And the human eye can perceive only a small portion from the electromagnetic spectrum. This portion from the electromagnetic spectrum, extending from 400 nanometer up to 700 nanometer, can be perceived by the eye, and the eye cannot perceive anything outside this range, like infrared, which can be sensed well by some animals. It might be interesting, and it does worth, to have an idea about some animals' visual systems so that we can understand our limitations, the human eye limitation. If we take some examples from the animals and from wildlife to see where are we in this planet compared to these creatures, to understand our limitations from one respect, and also to understand the visual system of these animals from other respects, especially the animals that we are dealing with. These informations will provide you with a knowledge how to deal with these animals. Let's take the horse, for example. The horse has side eyes, not front eyes like a human. And when he takes his food, the frontal area in the head is considered blind for him. But this was substituted by some hair near the jaw, sometimes called the third eye of the horse. And there was an interesting experiment done. They mixed the food of the horse with the sawdust, and they saw how the horse picking his food, which was mixed up with this sawdust, in a very precise way. These tiny hair sensors are considered the third eye of the horse and are part of the horse visual system. Also for the people who are dealing with equestrian and for the horse groomers, they should know some interesting information about the horse visual system. There is a neural connection between the ears and eyes of the horse. When the horse moves his eye, his ear moves accordingly, moves in a particular direction relative to the eye movement. When the knight is riding the horse, he can know where the horse looks based on the movement of the ear. Also, a knight riding a horse and jumping a fence. The way the horse sees the fence is different from the knight does. So, if the knight doesn't know this information, it might happen that he will jump from a point where the fence appears blurred, out of focus relative to the horse. So the horse will not be able to make it, and the knight may be thrown off the back of the horse. Another example is the hook. If we look closely at the eye of the hook, the size of the eye is large relative to the size of the head. The hook has a very strong visual system. It can spot a fish inside the water from a 2,000 feet height. Another strange feature, it can zoom. It can enlarge the scene up to 3 times, 3x by modern camera language. The owl can see infrared. It can hunt a mouse quite far in the night easily. Birds which hunt fish near the seashore, like pelican, they can see polarized light. If you look at the water as a human, you cannot see anything underneath. For these creatures, they can. One type of fish called the four-eyed fish, and in fact, it doesn't have four eyes. It has two eyes, but each is divided in two parts. One can see above water, and the other part sees underwater. Accordingly, this type of fish, which normally will be near the surface of the water, can see the insects and the food above the water, and the lower part of the eye maintains the surveillance underwater. Mantis shrimp. Mantis shrimp has a very strange type of eyes, as if it were built on a telescope. It can see 3D. If you want to go to the theater for a 3D movie, you need a 3D glasses. Mantis shrimp has these glasses. It can see in 3 dimension. It can see ultraviolet light. It has a very strong ability to distinguish colors compared to human. The chameleon. Chameleon can move each eye in a different direction. Each eye can search separately for the prey, and when the prey is spotted, both eyes will move in one direction, in the direction of the prey. The vision of the two eyes will be united, and it will focus, and it will make the hunt in a flash speed by its extremely long tongue. Housefly. The fly, like any other insect, has what we call the compound eye, an enormous number of lenses inside the eye. It can see in a very fast and complicated way, and this is why it's very difficult to swat a fly, because it moves much faster than the human movement. The honeybee. The bee can see ultraviolet light, so the flowers will appear to the bee's eye incandescent, like incandescent lamps. And this Allah gifted feature for the bee enables it to see its bread easily. Now we'll come to the human eye itself. A human eye consists of 3 main parts. The eyeball itself with its different parts, the optic nerve, which transmits the signals to the brain, and the visual cortex at the back of the brain, where these signals combined, interrupted, and the picture formed. This is similar to the camera system. The camera has the lens, which is the receiving device, sensing device, cables and wires, and processor available inside the camera, where the signals are processed and the picture formed. For the human eye, the first part which receives the light is the cornea. Cornea is transparent like a window, and the glory be to Allah, it doesn't have any blood vessels, which is important to gather the light without any obstruction. It serves in gathering the light and projecting it on the retina. Behind the cornea comes the iris. The iris is that part of the eye which gives the eye its color: black, blue, green, etc. Inside the iris there is an opening called the pupil, which gets narrow or wide based on the amount of light. So in bright conditions it will get narrow, while in low lighting condition it gets wider. After this comes the lens, and for the lens maybe there is no camera in the world which has the features the human eye lens has, because generally for lenses the light rays will be collected on a plane called the image plane. At this plane the image will be clear, in focus. If the distance changed, the image will be out of focus. In this condition, for camera and for lenses, the distance between the image and the lens will be adjusted to get a clear image. And normally this image plane in camera is where the image sensor is placed. But for human eyes, the distance between the image plane, which is the retina, and the lens is constant. So to deal with far object as well as near objects, the lens of the human eye will adjust itself. It will get narrow or wider based on the distance of the object from the eye in a mechanism called in cameras autofocusing, but in a very fast and precise way. So if you are reading a newspaper and looking at a far object and moving your eyes between the newspaper and the far object, the focal length of your eye will be adjusted very fast, almost in zero time, so that you will see both scenes, the newspaper and the far object, very clearly. If you do this with a camera, moving from far object to near object, you will notice that there is a time to refocus when moving from one object to the other. After that, the light rays will be projected on the retina. The retina is very, very complicated part of the eye. It has millions of sensors or photoreceptors. And these photoreceptors are two types. One of them is cone-shaped, the other is rod-shaped. So they are called cones and rods. Cones are responsible for colors and the image details, while rods are responsible for the brightness. They are used mainly in low lighting conditions. And that's why in low lighting condition, the image will be grayscale, almost black and white. These photoreceptors are distributed on the entire retina, except for a small part, which is called the optic disc at the end of the optic nerve. And it's called the blind spot because there is no photoreceptors, but this will be substituted by the brain. The brain will complete the image by collecting the information from both eyes. And since we have two eyes, the information coming from both eyes are sent to the brain, to the visual cortex at the back of the brain in a very, very complicated way. The optic nerve of the right eye is directed to the left side of the brain, while the optic nerve connecting the left eye is directed to the right hand side of the brain. And there is a crossing. At this crossing, in this intersection, information from each eye is routed to both sides of the brain. The brain will collect all this information to draw the three-dimensional image. The retina itself consists of 10 layers. When the photoreceptors receive the light energy will be converted into electrochemical energy, which will produce neural pulses. These neural pulses get amplified, and each cone-shaped photoreceptor has its own boosting station, while for the rods, maybe up to 20 of them can have one boosting station. And after getting amplified, these neural pulses are sent through the optic nerve to the brain, to the visual cortex at the backside of the brain. These signals are interpreted there at the brain to form the image with its relevant color, brightness, and depth. Now, what about the moving picture? For the brain, it can process 25 images in 1 second, which means that each image needs around 40 milliseconds to be processed, not less than that, which means up to 25 images per second can be processed by the brain. What if the number of images is more than that or less than that? If the number of images is more than this, the brain cannot cope with that, and we will see continuous image, like if you are looking at a fan moving fast, This feature of the human eye led from the beginning, when the movies were projected on the screen by the sign reel player, it was projecting 24 or 25 images per second, which made it convenient to watch such movies. If the number of images decreased less than 25 images per second, say 15 or 10 or 5, the breaks in the moving picture will be noticeable. That's why 25 images per second or 25 frames per second is called in video technology the real time. There is an interesting information here. If we are talking about the eye itself, the sensing device, sensing element, we are talking about what is called in English sight, and what is processed by the brain is called vision. There's a difference between sight and vision. We mentioned that the brain needs 40 milliseconds to process one image. What if an image is given to the brain for a very short time, say 15 milliseconds or 5 milliseconds? What will happen? For your eye, you will not see that. For your brain, it will. Because any information sent to the brain will be captured there. And there was an interesting experiment done in the theater. While playing the movie, they projected a statement which says, buy popcorn and Pepsi, for a very short time, less than 40 milliseconds, say 20 or 15 milliseconds. And this was projected repeatedly. When the people got out from the theater, they found themselves as driven by inspiration to buy popcorn and Pepsi. Something there in their brains driving them to buy popcorn and Pepsi. They didn't see this statement, but their brains did.